Welcome everybody to tonight's San Francisco Bay Area
ACM meeting. So like most everybody's taking a seat. Tonight's talk is Bitcoin plus blockchain architectures, stablecoins, and its transformative potential. So this is a little bit about San Francisco Bay Area ACM. So we're a local chapter of the Association of Computing Machinery. How many people are new to hearing about ACM? Okay, it's like a professional society for computer science, just like IEEE is for electrical engineering. And we're a local professional chapter in the Bay Area. So we've been having talks since 1957. So while we are on Meetup, we're a bit older than Meetup.
So we
are to promote knowledge of modern computing. We want to create community, support networking and hiring. There's just a $20 annual membership.
You can see our
upcoming talks
on Meetup.
And we have 200, 250 past talks on our YouTube channel that you can look at. So we generally have 2 monthly meetings. If it all goes well, fourth Monday of the month would be data science, third Wednesday of the month might be general computing, and all other topics. So for the people, you can use chat for questions, and there'll be a moderator that can ask the speaker questions. We are a volunteer organization. We're a 501c3 nonprofit. So just like NPR, we welcome if other people want to help out one way or another. It could just be, greeting at the front door, getting people signed up, picking a pizza, booking speakers, doing technical things. Something that I've heard in our monthly planning meeting is wanting to do social media, doing more promotions on social media. So if you're interested in that,
we can start off with a small area.
So we have a long list of upcoming ACM events, I'm happy to say. So coming up Thursday, February 6th is the AI Day in San Francisco. I've got a full screen on that in the following slide, and that's what this sign is for. So you can go at AI Day SF. Then on February 11th, there's Bay High in San Francisco, chasing fire, matching strategy to today's greatest challenges. Then in the February talk will be ACM Distinguished Speaker. So the ACM Central organization has a Distinguished Speaker program that once or twice a year will pull speakers from that are kind of national level speakers. So this person happens to be in the Bay Area. But he'll be talking about building advanced AI applications and agents in 1 hour. So our March data science talk will be by me, Gen AI, best practices for implementing RAG and enterprises. And I'll have a talk
In March, end of March, and then in April
or May. Then I'll give a day-long training class. We call it PDS, Professional Development Center. So then if you want to get some hands-on programming experience relating to the RAG, then I'll be doing that later on. I'm going to send out a survey asking potential people who would come different questions.
like it
speak a little bit this way or that way. You have a particular vertical you like. You have
and other questions. So AI Day in San Francisco.
Ron, did you want to speak to this?
Yeah. Hello, everyone. Thanks for coming. My name is Ron. Oh, could we turn up the volume? Thanks, everyone, for coming. Just going to hawk AI Day here. So AI Day, the point of it is to get out of our myopic view of AI. So the idea is to have a full day of training, thought leadership. The training itself is in 2 sessions. In the morning, we'll look at HGPT and agentic AI. What does that look like? Kind of what's the state of the kind of commercial space regarding agentic type systems. And then in the afternoon, we'll look at machine learning toolkits. We have some of the Kubeflow project community flying in to teach us what's going on with Kubeflow, how to use it. So again, 2 different sessions. So that'll take us through the afternoon. And then in the evening, we got thought leadership where we have both public and private sectors coming in. We've got legal, medical, technology, commerce. And the idea is for people from these different sectors to actually talk about AI that's happening today. Not something that might happen a year from now, but what is, example I like to give is in the legal sector, it's like, what's actually going to get me sued right now? Right. And so that's kind of the idea, right? And then it's not all bad, right? Like what's good, right? If I do the right thing, what can I do to maximize that? So the idea again is to have a whole wide range of society come talk. This is in partnership with the Internet Society, and so it's a dual fundraiser. So the plan is to split the proceeds 50-50. And we would love for you to come and contribute and participate. And if you don't code, this comes up a lot. If you don't code, don't worry. We're not, it's gonna be some code, but not a ton of code. It really is about the systems, seeing what they actually do. We're not trying to recreate some LLM or anything like that. This is just, what is the current useful, practical utility of these tools and impact on society. So please check it out. We have plenty more seats and we'd love to have you. So this is by the way, I should point that out. It's in Google community space. You know where the big bow arrow is on the Embarcadero? It's right there. The great spot, food included. Please sign up.
This is why I have a trip along the way.
Yes.
Is this an intimate setting or is it a large group?
80 max.
Nice.
80 max. Yeah. Thanks, sir.
And don't forget to turn off your cell phone sounds.
Okay, so let me introduce tonight's talk.
So the subject, blockchain has architectural features and differences that enable security, transparency, and decentralization.
Decentralization.
She'll cover the types of blockchains,
Public, private, and consortium. She'll introduce stablecoin.
which is pegged to assets such as fiat currencies or commodities. Applications and supply chain management, decentralized finance, and healthcare.
And evolving regulatory landscape.
Her background, she's a product manager with expertise in financial services. Now she's at Barclays Bank as part of the prime brokerage business, a fellow member of the Economic Club of New York, and I've listed her LinkedIn profile there if you're interested. So let's all give some applause and welcome our speaker.
Thank you very much for having me here today. Thank you for coming in person, and for those of you joining virtually, thank you for your participation as well. Today's topic is going to be about blockchain technology, the different types of blockchain, as well as its real-world applications. Today's talk is especially time considering the administration that has been in office for about a week. We've already seen some executive orders signed, so I personally think this is a great time to learn about blockchain technology, not just about crypto specifically, and just get your hands dirty and see the real world applications. Just so you understand, who in this room has either bought a crypto before, sold a crypto before, has some exposure to crypto? Okay, great. That's a good amount. Who in this room has worked with blockchain technology outside of crypto? Okay, that's great. Would you be willing to share your experience after this presentation? Okay, that'll be great. Thank you. We want to make sure this is like a learning exercise for all of us, so I'd love to hear from you as well. Getting into today's presentation, before we get into it, just two housekeeping items. The views expressed in this presentation are my own. They don't represent anything of my current employer or my past. The views expressed are just for educational purposes. They don't represent financial advice. Please do not sell your 401k and go and buy Bitcoin after this is over. I know it's all very exciting, but let's just take it as it comes. Thank you. Greg already covered the agenda for today, so I'm going to skip the slide, and we're going to go into studying the evolution of money. I believe studying history is like a very key aspect because it...
Just a question, sometimes
People take pictures of slides. Do you mind emailing me a PDF of the slides later on, and I can...
Yeah, absolutely. Yeah, absolutely. I truly believe studying history is an important exercise. Studying the past helps us understand where we are today and where we might end up in the future. So that being said, let's take a few steps back and understand the evolution of money. In about 6000 BC, what we typically had was something called a barter system. So there was no concept of physical money at this point, but people exchanged goods and services for one another. So for example, there would be a farmer who would have wheat, another person who would have cattle, and the farmer who wants wheat wants milk, and the guy who has cattle wants wheat, and they would enter into a trade. This formed a foundation of trade as we understand today, whether it's in a local context or a global context. The barter system is extremely important and help lay down this foundation for us. Next, we have 600 BC to 700 BC, we started seeing coins for the first time. These were usually metal coins. What we realized during the barter system is that the products or the goods or services that were being exchanged were perishable in nature, which required these to be exchanged within a certain window, which is why we invented the concept of coins. These metal coins made out of gold, silver, copper, they were usually authorized by certain government entities that existed during that time and created trade much easier. Then during the 11th century, we saw the advent of paper money. This came at a time where international trade was just beginning. So as you can imagine, taking a bag full of gold or silver coins and trading internationally was very inconvenient. These coins were very heavy, which is why we invented paper money. And then in the 1950s and the 1960s, we saw the advent of the credit card or the debit card, which is still used widely today. Essentially, we don't need to carry paper money, and we just have a card with hopefully thousands and thousands of dollars that you can use to your disposal. In 2009, we saw Bitcoin come into being. Does anyone want to take a guess as to what was going on in the world around this time that resulted in the advent of the Bitcoin?
Loss of confidence in fiat currencies.
Exactly. So just for the people who didn't hear, the gentleman said loss of confidence in fiat currencies because of the financial crisis, which is absolutely true. In 2008, we saw one of the largest global financial crises. It was the largest after the Great Depression. We saw a number of financial institutions, large banks and organizations just collapse. The need for having a decentralized financial platform came into light, and that's when we saw Bitcoin come in 2009. So how did Bitcoin evolve? The evolution of Bitcoin can be traced back to one specific event. It was the day when Satoshi Nakamoto released this paper, which is called Bitcoin, a peer-to-peer electronic cash system. The paper was released on October 31st, 2008. In his paper, he highlights the importance of a decentralized financial system. He talks about Bitcoin. He talks about how Bitcoin is not an unlimited resource. There are only 21 million Bitcoins in the world that can ever be mined. He talks about having cryptography and having algorithms to mine these Bitcoins and how people would get incentivized when they mine these Bitcoins. So this really laid a foundation for what we understand about Bitcoin and blockchain today. The first block on the Bitcoin, which is called block 0, is also called the Genesis block, which is what you see here on the slide. This Genesis block, or the block 0, has a very important significance because it is the first block on the blockchain, and it'll always be the first block on the blockchain. There is also a symbolic representation on this block. If you look closely towards the right-hand side of the slide, you will see that it has a special message encoded in there. It says, "The Times, 3rd January 2009, Chancellor on brink of second bailout for banks." This matches the exact description that we see on the Times paper, which you see on the left-hand side of the slide. There is a symbolic meaning to this because Satoshi Nakamoto is trying to hint that the financial institutions that we put our trust in and we put all our money in are collapsing. And here we have this new technology that's ready to shape the world. So it was on this day that he mined 50 Bitcoins, and that's considered to be the Genesis block. Now, there's a very interesting story of how Bitcoin was monetized. You see, up to this point, Bitcoin is only considered as a technology. It hasn't been used to trade. The first time Bitcoin was monetized was on May 22nd, 2010. This day is called the Bitcoin Pizza Day. It's the day where there was a gentleman called Lazao who paid 10,000 Bitcoins to purchase 2 pizzas, which was the equivalent of 41 US dollars at that time. So he essentially took a speculative asset, sold it, and bought 2 pizzas out of it, which is the first time Bitcoin was actually monetized, which I think is a very interesting story. So we've talked about Bitcoin quite a bit. We understand the history, but let's take a deep dive into the architecture that supports this technology, which is the blockchain technology. There are way too many definitions out there for blockchain technology. Personally, I think you can use whatever works for you and what makes most sense to you. But it's really important to have a layman understanding of what this technology is. So for me, the way I like to understand it is if I have a database and it's a write-only database, I can't delete statements or entries from it. I can only insert statements and add to this database. And every time I add something to this database, everyone in this room has to verify that transaction. So I can't be adding random things to this database. This forms something that we call a consensus algorithm. So if you read this definition that's on this slide, it says, blockchain is a constantly growing distributed ledger that keeps a permanent record of all transactions that have taken place in a secure, chronological, and immutable way. This is what really differentiates blockchain from other technologies that have existed in the past. It's immutable. You can't change the entries once they've entered. It's in a chronological way. So you know what is block 0, you know what is block 1, you know what is block 10, and that never really changes. In order to have an appreciation for the distributed ledger, it's really important to take a step back and understand the other types of ledgers that were available to us. So in this slide, you first see the centralized ledger, where you have can you guys hear me? Okay.
I feel like
Yeah. So we first have the centralized ledger where if you see you have one central node, which is the node in the white, and all the other nodes in the blue are connected to that single central node. In the second, sorry about that. So how does a blockchain work? the main concept of a blockchain is to be able to send a block from one person to another, or a transaction from one person to another. So let's say in this example, person A wants to send money to person B. This transaction is represented in a block. It is securely stored using a cryptographic hash function, and this block is broadcasted to everybody on the network. Once the block has been broadcasted to everybody on the network, we need each party to approve this transaction, which we call a consensus algorithm, which we'll study in just a few slides. This block is finally added to the existing blockchain. Like we've discussed before, this is an immutable block. You cannot change this transaction, and the transaction is finally marked as complete. So this is the entire flow of the blockchain. We've discussed quite a bit about this blockchain being immutable, but what does that really mean? If you look at this slide, it gives you an understanding of the size of the Bitcoin blockchain. When we started off in January 2009, this is obviously 0 MB. And as of this morning, we're at about 632 gigabytes for the Bitcoin blockchain, because we keep adding blocks to this.
Why did it fall off and flatten at the end?
It's because of the timescales. You see, it's like 2000,
okay.
the x-axis. So there is quite a bit of interest in the crypto market, but just to put some numbers around this and put things into perspective, if you think about the market capitalization of the crypto market, which includes all cryptocurrencies that are available, as of this morning, it was about 3.67 trillion. Does anyone want to guess what is the market capitalization of all the FANG companies combined? Just a wild guess.
6 trillion.
620?
6 trillion.
6 trillion? Okay, anyone else? It's about 9.4 trillion as of this morning. And that helps put things into perspective. The crypto market is fairly sizable as it stands today. And like we discussed before this presentation started, given the incoming administration and the policies that they have, we would likely see this grow in size. An important and interesting player in the blockchain world are miners. Miners are like little soldiers that are in this blockchain community. They have three main functions. The first one is to validate all transactions and make sure that they're accurate. The second one is to enable block creation. So we want to ensure that these miners are creating these new blocks that are then made available for people like you and me to transact on. And then finally is to ensure network security. The blockchain is a distributed ledger. It's very important that it is secure and it's fault tolerant. Bitcoin miners or blockchain miners do help support this. There is an incentive for Bitcoin miners. As of this morning, if you're a Bitcoin miner and you mine one block, your incentive is that you would get rewarded 6.25 Bitcoins. The price of a Bitcoin is about upwards of $100,000. So if you do the math, for a few minutes of work, if you have the right computer and the right equipment, that's quite a lot of money. Getting into the types of blockchain, there are four main types of blockchain that are available to us. The type of blockchain you use will depend on your business use case or what you're trying to achieve. The first one is a public blockchain. Think about Bitcoin. It's available to everyone with a computer. That is considered a public blockchain. A private blockchain, in contrast, is something that's available only to a few people. So think about like a supply chain organization, or like any organization with data on the blockchain. It would have a private blockchain because it doesn't want to ensure that other people have access to it. The consortium blockchain is when there are two or more organizations who have access to the specific blockchain. And a semi-private blockchain is a combination of public and private blockchain, which is maintained by multiple organizations as well. So which one you use really depends on your ultimate use case. An important aspect when it comes to blockchain technology is understanding cryptography and how cryptography works. So cryptography is derived from two words: cryptos, which means hidden, and graphein, which means to write. In the simplest terms, cryptography is nothing but the art of writing or solving code. There are a few terms when it comes to cryptography that are important for us to understand. So this slide just explains those. You have encryption, which is the process of converting plain text into ciphertext. You have decryption, which is the process of converting ciphertext into plain text. You have a cipher, which is your mathematical function. And then you have a key, which is information required by the cipher to produce the output. Now getting into the types of cryptography. So you have symmetric cryptography, where you use a single key to encrypt and decrypt. So between your plain text and ciphertext, and converting from your ciphertext to your plain text, you use the same key, which is called asymmetric cryptography. The next type of cryptography is asymmetric cryptography, where you would use two types of keys. So you have a public key that is used to convert from your plain text to your ciphertext. And then finally, a secret key to convert from your ciphertext to your plain text. When it comes to blockchain, we use a special type of cryptography, which is called hash functions. Hash functions are like mathematical algorithms. They take an input and they produce an output of a specific length. Most commonly used hash function when it comes to Bitcoin is SHA 256. The 256 in there really stands for the number of bytes that I use. So if I pass it a long string of text, it'll consistently give out 256 bytes of data as its output. So the key characteristics of a hash function are that it's deterministic. I know what the output size is going to be. It's always a one-way function. So I can convert from a plain text to a ciphertext, but I can't convert from a ciphertext to a plain text using a hash function like we did using our keys in cryptography. And it's collision resistant, which means that no two hash functions can have the same input. You would have a different hash function or a different hash output because you provided a different input. Another important aspect when it comes to blockchain technology is the use of consensus algorithm. This is what really helps drive the distributed ledger system that blockchain depends on. So consensus algorithms are mechanisms used by distributed systems to ensure that all participants agree on the shared state of the system. So when we talked about our example of the shared database and we were writing into the shared database, I said that this shared database would have transactions that are validated by all of us. So only if we are all in consensus of what the shared database looks like, would it be considered part of the blockchain? Otherwise, it's not. So the key goal is to make sure that everyone agrees on the state of the blockchain. There is fault tolerance, which means that if there are malicious activities or people trying to attack our blockchain, we can ensure that this doesn't happen with consensus algorithms. And then finally, decentralization. There's no central intermediary or a bank or an institution that's governing this, which makes the role of the consensus algorithm really important. Now getting into smart contracts. Smart contracts rely on blockchain technology. They're essentially digital contracts that are automatically enforced when an event arises. This is a key application of blockchain technology that we see commonly adopted in the industry outside of cryptocurrencies. It essentially ensures that once an event has occurred, your funds are transferred, for example, or once an event has occurred, it leads to another event. So you can really use smart contracts in many industries to ensure that your end goal is met. The key features are automation, transparency, decentralization, immutability, and cost efficiency. It really ensures that you don't have to have a lot of people involved, and you can sort of automate this entire process. So smart contracts, how do smart contracts work? When you write a smart contract, it's like any legal agreement. You define your contract requirements. You deploy the smart contract, which is usually done on the blockchain. You execute the smart contract, so you wait for the event to occur. And once that event occurs at the predefined time, you execute the contract. And then finally, the transaction or event is executed and the results are recorded in an immutable blockchain. Another common theme that we typically see in the crypto world are the use of stablecoins. They have been gaining popularity in the recent years. It's primarily because, as we understand, cryptocurrencies are quite volatile, and the use of stablecoins essentially helps us mitigate some of that volatility and the risk. So the first stablecoins were invented, I think it was in 2014. And they're typically pegged against another asset. So you can have them pegged against a fiat currency, you can have them pegged against a commodity, or even another cryptocurrency. First type of stablecoin that we see is a fiat collateralized stablecoin, which means that this where they're backed by a fiat currency. It's usually a US dollar or a euro or a JPY. They're pegged in a 1-to-1 ratio, which means $1 US means 1 Bitcoin in this case. And some examples are US Tether or US Coin. Another type of stablecoin is a commodity-backed stablecoins, where, as in the previous case, we saw they were pegged against a currency. In this case, they're pegged against a commodity, which is something like a gold, silver, or some other commodity. In this case, an example is one token would be pegged against a gram of gold. And an example of this is Pax Gold. Another type of stablecoins are crypto-backed stablecoins. These are usually over-collateralized. So in the previous cases, we saw them that they are in a 1-to-1 ratio. Usually in this case, it's never in a 1-to-1 ratio. You have typically $150 worth of cryptocurrency backed by $100 of stablecoin, just to offset that volatility risk that we see when we're working with cryptocurrencies. An example of this is DAI, which is collateralized by Ethereum and other crypto assets. And then finally, we have algorithmic stablecoins. I like to think of these as like smart contracts as well, because what it essentially says is that once certain conditions are met, when the price goes low, do X. When the price goes high, do Y, which can be interpreted as a type of a smart contract. And an example of this is Ampleford. About a lot of concepts around blockchain, around Bitcoin, stable coins, and smart contracts. But what really differentiates these from technologies that have already existed? It's really important to understand this because it helps us understand the different use cases outside of the financial industry and where we can use this technology. So we know the blockchain is immutable. Once a transaction is on the blockchain, you can't edit it. We know it's pseudonymous in the way that there's no person that you can identify. You can identify the address associated with the blockchain, but it's still pseudonymous. It is traceable. It is programmable, like we saw with the smart contracts. It can be tokenized, and then I can do micropayments with it as opposed to having some sort of a minimum spend, if you will, like I do with my traditional financial institutions. So just getting into some real world applications of blockchain outside of finance. One that I found particularly interesting is the sourcing of vanilla. So about 80% of the world's vanilla comes from an island in the Indian Ocean. It's called Madagascar. Obviously, this vanilla is used heavily, whether it's in the cosmetic industry or whether it's in food. But almost all the vanilla in the world comes from this little island. Traditionally, the farmers use a stamp called the fitombica. That is what you see in the slide on the right, to identify which farmer harvested that vanilla. But with the use of blockchain technology, you can actually digitize this stamp that was traditionally used into a more digital stamp, and you can trace the source of vanilla from the farmer to your doorstep to ensure that you're getting the most ethically sourced vanilla. This slide covers the real world application when it comes to real estate. I know one person in this group is particularly interested in this, so I'm just going to let this play.
Fortunately, on the development, sales and facilitated. Services $1,000. Traditional. $1,000.
I want us to go from the start. No.
Go back to the beginning.
Using some video. I can sell those systems to a variety of both institutional and individual investors. Meanwhile, Sarah now has the ability to make real estate investments at practical cost is required. I use the
Start again. Okay. This is why we have post edit.
Yeah.
Don't you worry, we're good at that. Why can't you beautiful?
I know.
Yeah.
Meridio is a blockchain-based platform for fractional ownership of real estate. Here's how it works.
another video.
So what is this recording?
Normal.
I have no idea.
We can fix it later. Okay.
Okay, great. That was one example. I have another one here, and this is the last of the slides, and we're good for questions after this one.
HesabPay tries to help people receive funds wherever they are in the world. We particularly focus on very difficult jurisdictions, areas where there might not be any banks. .6% of the population had a bank account. This is never works when it comes to HesabPay is the first time that we get to overall digital payment.
Great. That was the last of my slides. Before we start for questions, does anyone want to share their own experience with blockchain technology? Oh, okay, great. Why don't, oh, go ahead.
Can you repeat the questions for the remote?
The question is how many Bitcoins are mined every day? It's an exponential function, as you can imagine. It's not linear. It depends on the compute capacity, which has been evolving over the years. To give you a number, there's about 19.2 that have been mined up to date. And we started mining in 2009 in January. So that gives you a ballpark of how long it takes. And it obviously requires a lot of power, a lot of energy. So there's a really good website that I use for that, but it's pretty easy to pick that up. But the reason I had all of crypto was just to sort of show you the industry-wide trend and not just focus on Bitcoin.
Can you repeat what the question is?
Oh, sorry. The question was the slide about the market capitalization at all cryptocurrencies and not just Bitcoin. Is there a figure available just for Bitcoin? And that one says yes, there is. I can provide the link to the website, which is updated real time.
I got one.
Okay, great.
Do you have any idea on bugs, vulnerabilities found out in the last few years? Wanting to know how secure is it?
As you can imagine, this works on a consensus algorithm. So bugs and security issues are predominant in technologies like this. But Bitcoin specifically is considered a industry standard. And it's even being considered to be adopted by the US as part of our reserves. So it really depends on what cryptocurrency you're working with, but Bitcoin definitely has been one that's been used for a while now. Yeah.
It's great. I really like the HesabPay.
Yeah.
Couple questions. One, I mean, the whole thing is that it's unbreakable, right? But with quantum computing, can we break Bitcoin? We reverse engineer, learn who we're selling to, get rid of the Sue and the pseudonymous.
Yeah. So the question is, Bitcoin is considered unbreakable. And the question is, with quantum computing, can we break it? Can we understand who the transaction is from instead of being pseudonymous? Is there a way to identify who these people are? It's a bit hard to know. The foundation of this entire technology is that it's unbreakable and that it's pseudonymous. Obviously, with the government coming into play, we don't know what policies they're going to come up with. Are they going to make it mandatory for people to identify who the transactions are to and from? We don't know. But as it stands today, the technology doesn't support it.
I can add one comment on the post-quantum encryption. At our last event, Global Encryption Day, we had the head of the Linux Foundation post-quantum group talk. And basically they said, if you're using AES 256 for storage, for now, we look like we're good. But for PKI and, smaller symmetric keys, things like that, maybe not. But for storage, we should at least get to retirement. Okay. And then maybe all bets are off after that. But
one way or another, that's for sure.
Yeah, but you our the website, all the presentations from that, including him, the videos are all there. That's it. Thank you.
Question: Bitcoin mining, is that a constant amount of compute per Bitcoin being mined, or does it increase over time, like the same amount of computation in, say, 2010 versus 2020? Is there an effect of, as there's more Bitcoins out there, the mining gets to be more computation?
That's a good question. There is a concept of a difficulty level associated with every block on the blockchain. So as in when the difficulty level goes up, you would have more compute, and when there's lower difficulty levels, you would need less compute.
What's the criteria to increase or decrease that?
Yeah, sure, go ahead.
Oh, okay.
It's just the shrink. There's like a random value you try to recalculate, and they just shrink hours of two.
The size of the part. Yeah, the size of the part. So you need to get a block that has a certain number of zeros that we need to hash. And you get a lot of hashing power, you'll find that sooner. So they will basically say, well, now you need to find more zeros at the beginning
Okay.
for the next period. And that will make it harder. So that the aim is to get a block of. Okay.
Sure, go ahead.
Yeah, I have two questions. One is the kind of the computational load associated with transactions. So you mentioned that the size of the Bitcoin ledger now is like, I don't know, some huge number, but it seems like if people want to be able to, does it mean that like the amount of work that has to be done to update all these ledgers, if I want to be able to go buy something like a donut with Bitcoin, that seems highly impractical. A, because of the dollar value. It's like if it's $100 grand, I want to go buy 0.000 to buy a donut or or a piece of toast or a coffee. And then it also seems like the computational is really crazy. Are there some coins like the Algorand that seem like maybe the transaction load is lighter or it's faster or more conducive to a micropayment system, whereas then Bitcoin becomes more of a stored value because of the computational load? Can you talk a little bit about that? And then related to that is this fractionalization, is that you talked about, well, there's a block and we're keeping track of stuff, but the size of Bitcoin now is worth so much money. It's like nobody's moving whole Bitcoins, or maybe I guess governments, institutions, big people are, but a lot of people are just moving little chunks of it. And then how does that work if it's if I'm going to give you a 0.00001 Bitcoin to pay for the pizza, how does that get recorded? If it's all this, if it keeps getting fractionalized, that just seems like that gets complicationally weird and challenging. Can you talk a little bit about that?
Yeah, sure. So with most things in life and most things in the financial institutions, there's only a monetary value assigned to something based on the value that people decide to buy and sell it for, right? So why is Bitcoin trading at 100,000 today? Is because of demand and supply. If you were to sort of do the same transaction using, let's say, your Apple Pay, right? Buy a pizza. There's again supply and demand there, right? Your bank account is nothing but just a bunch of ones and zeros in it. There is obviously transaction cost associated with when you're using your traditional financial institutions. But that's the whole point of blockchain, is that you don't have that transaction cost associated with it. So people aren't really concerned about fractional Bitcoins or using fractional Bitcoins. That was the whole purpose of developing the technology. And tokenization is like sort of the key concept, right? Like we saw in the example with the real estate, with the house, you have a large apartment building, it's broken down into multiple tokens. That's primarily the use case for it.
So the processing speed is uniform amongst these different cryptographic coins and tokens. Like, no, there's not one that's faster.
So we open file.
Yeah.
It's the same speed as the Visa name.
Okay.
Like 5,000 transactions per second.
Wow.
Yeah.
That's
Because they don't use proof of work. They use some sort of stack. I don't know how.
I think it's proof of stake that they use. Yeah. So essentially it means that if you have a stake in Ethereum, so you own Ethereum, then you get to vote on whether it's part of the block or not. Versus like for Bitcoin, you don't need proof of stake. You could be a miner even if you don't have a stake in Bitcoin.
So it's not a small transaction.
Yeah.
It costs you about on all some L every transaction every time. How much? I think it's 30 cents today. 1 L for 1.
Thank you.
Yeah, sure.
I guess mine's kind of related to that, but I'm just trying to understand what a block is. You said each transaction is a block, but then you said a miner gets compensated $600,000 per block. And so I'm trying to understand if I, how let's say a 1/100th of 1 cent transaction, certainly you're not paying $600,000 to a miner to validate that. So I don't know, I'm just trying to understand how those two things relate, what a block means.
Yeah.
Yeah.
So the dollar value assigned to a block is what gets assigned in the financial institution, right? But when this technology was developed by Satoshi Nakamoto, there wasn't a dollar value associated with it. So in other words, when we started in 2009, a Bitcoin block was worth nothing, right? It was only when you have your National Pizza Day, is when there was some dollar value assigned to it. When we say a Bitcoin miner gets 6.25 Bitcoins for mining a block, that they get 6.25 Bitcoins. That doesn't signify the dollar value assigned to it at that time. You could technically take those Bitcoins and sell them in the open market or send them to someone else, but that really depends on the value that's assigned to the Bitcoin at that time.
But okay, so like if I did a transaction for a 1/10 of a penny,
Mhm.
would that be a block?
So a block would be 1 megabyte, megabyte. Or you can pay nothing if no one wants to make any transaction.
Okay, so a whole bunch of transactions get put together
Into that block.
into one block.
Whoever mines that block and takes those and writes them into that block.
Okay.
Yeah.
Okay, and so, would those all have to be my transactions or?
No.
It's everything on the network that's pending.
Okay,
And is mining something that only happens once when it's created, or is it constantly?
Every miner is trying to find the next block. Finds it, gets the reward, and everybody else has to start over with the new chain. Everyone has to start over. Since they it's a random.
Yeah. It's a big distinction between like a transaction. If I give you a bunch of Bitcoin, that's a transaction versus the creation of
When
additional.
you make that transaction, yeah, that's right. But that can be only done when someone mines block. It's into.
so how, from the point of view of like, let's say you have to merge 1,000 transactions to get a full block.
Okay.
So let's say you had to concatenate 1,000 transactions to get one block, and those transactions are coming from all over the place. Who's to say that before it gets put into the block and then you validate the block, but who's to say that it's valid from going, like for me, to the stuff that's pending and to go into the block?
The miner is the one that performs. They write the block settlement, like it's not the transaction.
The settlement of the transaction is when it gets mined into a block.
Yeah.
So until it's mined, you cannot say that it's permanent or that it will be permanent or that it will be valid. It remains in a state like you can publish a transaction, but you can also publish a second transaction that invalidates that.
The mining
Whichever
is
gets-
writing to the ledger.
Exactly.
Whichever goes into the blockchain in a block is the one that becomes valid and settlements. Exactly. Yeah.
That's helpful. That's what's writing to the ledgers.
Yeah.
That's helpful.
Right, right. The blocks get
Validate,
validated.
Mine was the original creation of it. It's like.
You solve it, but then you pass it around and they get to validate that you solved it, but validation is instantaneous. Solving it the first time takes 10 minutes, right? If you're lucky, proving it takes a function call. So you have to pass it, so it takes time that's the distributed part of it.
Mining sounds like you're digging for gold and printing money,
Yeah.
but it's not. Mining is writing the ledger.
Well, Because we also talked about how there's only 21 million Bitcoin, but only so many of them have been.
Well, most of them have been mined already, more than 19 million.
Yeah, but that. Yeah, I guess
So that's what the halving is. When you mine a block, there's a reward, right? You mentioned 6.25.
Yeah.
Now, after 2024, you only get 3 1/8. So halved. Yeah, it's halved about every 4 years. So the supply is diminishing.
Yeah.
Is there gonna be any transactions in Bitcoin after 21 million is reached?
Well, but
Well, the idea was you need to pay the miner, you need to pay the miner at that time to do the work. Now they get the reward from the chain now, but after they run out, and you need to pay them the transaction
so that's
fee.
expected to be around 2140. You have some time to figure that out.
Other thing that could be of interest that is called actually avoiding a double spend. So after you do a transaction, till it is committed into the block, you kind of have your money. So it's like, I give you a check and I give another person another check, and when they check your bank account, you have the $100, but you have done a double spend. Because only after you cash it, the other one would bounce. So there are elaborate schemes to actually protect you from that thing, that double spend. So there's a partial commit and then there's a block commit. And when they say it's a block, it's actually a database transaction record. It's really that what it is. You need some data on a disk.
Maybe one more question?
Yes, I have another one too.
Right on.
Lots of questions. In the case like the Ethereum case where you said, let's say you had an escrow where you're gonna, once the house sells, you're gonna transfer the money. How does the event get verified? Like, who is it that verifies an event occurred that allows the transaction to proceed?
It's again people on the network, right? So it's like people who are part of your blockchain. And that's why you have these consortium algorithms, right? That's why you have your proof of work, your proof of stake. So every blockchain would have its own way of validating these transactions. There are miners who are validating these transactions, mining out new coins, but how that exactly gets done depends on the type of your blockchain. So for example, Ethereum has a different way of validating transactions as opposed to Bitcoin does.
Are you asking how the smart contract gets executed or not? Define how to.
Yeah, I mean, I imagine like, I'll pay you once the work is complete, right?
Mm-hmm.
So how does it, who determines when the work's complete? I mean, I guess that's how, the whole contract is sort of automatic, but I'm just wondering how these conditions get validated in a smart contract.
They're like any legal agreement, right? They're like fairly extensive in the event of defining how you determine that the event is complete or how that event has taken place. I think the simplest way to understand it is like, think of a smart fridge, right? If you run out of milk, you run out of milk. And then the fridge would just order new milk for you. So it's like a defined event. Versus like the real estate example is like a bit more complex to like wrap your head around.
Could do one more online?
Yeah.
All right. We're gonna do one more online question. This is from Amar. We have seen multiple occasions when stable coins have lost value, depegged like the US dollar in 2018 or the SVB collapse in 2023. So is there anything that has happened in recent time to give them more assurance of stability?
The short answer is not yet. But we are seeing some administrative changes with the new government. But the short answer is no. The Stablecoin, it's supposed to be stable because it's backed against the US dollar, but yes, he's right. There's no reforms in place right now to protect against that.
right, well, actually, thank you very much, everybody. Round of applause. I want to say, I thought I was hardcore from driving down from San Francisco to this. She flew in from New York. So maybe another round of applause. So thank you very much for presenting this. We thank you very much. We'll fix the audio issues in the post-production, so sorry about that, but not my first job, I guess. Thank you, everybody. So please hang out, eat pizza. We can stick around for another 30 minutes or so. And again, check out our next events, and we'd love to have you there. So thank you.
Just a comment, when she sends us slides in a PDF form, I'll post the slides on the meetup site. So I'll just add a link there. Used to meetup had a comment section, and I would ask the speakers just to post a link in the comment section, but they've taken that feature out. So I'll just work out a way to gather slides from the speakers, and then we can post that. I don't know if there's an easy way we can post the links on the YouTube site as well, but I'll look into it.
Thank you, everyone. Thank you very much.
Thank you.